Okay, so I wanted to jump on here for a minute and talk about some things we were talking about in our commercial wiring class about transformers and converting from the primary to the secondary side, how to convert voltages there. And this is just pretty simple math, right? We're just looking at ratios, right? There's a depending on how many windings the primary side has versus how many windings the secondary side has. We're going to be looking at the ratio between those two, and we're going to do the math to convert them from one to the other. So let's say we had a primary side with at 480 volts, and we're looking at it's a step down transformer, right? So if it's step down, that means it's going to get smaller with a 2-to-1 ratio. So if it has a 2-to-1 ratio, right, we're going to divide the 480 by 2 and get 240 volts on our secondary side, right? Pretty easy. That was pretty easy to do there. We can look at another one, right? So if we had a primary side that was 240 volts, and it was a step up transformer with a 1-to-40 ratio, right? Then we're going to multiply our 240 by 40 and get 9600 volts, right? And so if it's step up, it's going to get larger. If it's step down, it's going to get smaller, right? Well, what if we knew that our secondary was 480 volts, and it was a step down transformer with a 10-to-1 ratio, right? So if we know the secondary is 480, right, it's on this, and it's a step, and we're stepping down, then to get to the primary side, we're gonna have to go back up to get the primary side, right? So this would be 4,800 volts on the primary side, right? So it works, in both directions, right? So if it's a step down, right? If we're at 240 volts, if we have that and it's a step down 10-to-1, we're going to get 24 volts. And the same thing if we knew we had 24 volts, right? And it's a 10-to-1 ratio, it was a step down. We're not given the primary. If we were given the secondary, right, then we can work that backwards to instead of dividing by the 240 to get 24, we would multiply the 24 times 10 to get 240, right? So like it's dependent upon which thing that we're given, right? The other thing we want to talk about, right, is power, right? The amperage. I've mentioned in class before, right, that amperage and voltage, they have an inverse relationship, right? So if we double the voltage, then the amperage gets cut in half. You're going to use the same amount of voltamps either way, right? A light bulb, a motor, right? It's using a certain number of voltamps, and we can if we up the voltage, then we lessen the amount of amperage that it takes to run that motor or that light bulb or whatever it is. Well, a transformer, right, it has to have the same number of voltamps going in on one side as it has coming out on the other, right? So if we look back at that very first problem we did where we had 480 voltamps or 480 volts, with a 2-to-1 step down to 240 volts, right? If this is a 48 kVA, 48,000 voltamps, then we're going to have 48,000 voltamps here as well. So if I told you that on the primary side we had 48 kVA, and I asked you how many amps, what's the amperage draw going to be on the secondary side? Well, the volt amps will be the same, and so then we just have to do the math there, right? So we're going to take our 48,000 volt amps, right? kVA, that means 1,000 volt amps, so 48,000 volt amps. We're going to divide that by 240 volts, right? Our volts cancel, right? And then we take our 48,000, divide it by 240. We're going to get 200 amps, right? So that's a 200 amp service that we got there. I can do the math on the opposite side, right? If I gave you that same problem, I told you it had 48 kVA, 48,000 volt amps of power. What's the amperage on the primary side? Well, the amperage on the primary side, we're still just going to do the same math, 48,000, but this time instead of dividing by 240, we're going to divide by 480. So we divide by the 480, volt amps and volts. Our volts cancel, and we get 100 amps. You see, by our voltage cut in half, right? When we came from here to here, our voltage cut in half, and our amperage doubled, right? We divided by 2, we multiplied by 2. That's how that winds up working out. Let's look at that next problem we did, right? With 240 volts, and we were 40 to 1. No, we were stepping up. So we were 1 to 40 to give us 9,600 volts. Right? Well, let's say that this is once again 48 kVA, right? On this side, right? We just saw 48 kVA with 240 volts. That's 200 amps. Right? Well, if I asked you what it would be on the secondary side, right? It's still 48 kVA, right? Our volt amps is still the same. And so if we have moved our voltage, if we've moved our voltage up by 40, we have two ways we could do this, right? I can either take the 48,000 and divide by 9,600, or, right, I know that I went up by 40 here. I can divide that 200 amps by 40. $200 divided by 40 equals 5 amps. 48,000 divided by 9,600 equals 5 amps. Right? See, it works in both directions. Right? We're able to do that math, either way, right? I know my ratio is 1 to 40, so if I know my amperage on the primary side, I can divide it by that ratio to get my 5 amps. Or if I haven't worked this part yet, right? If I know that I have 48 kVA on the primary side, then I'm also going to have 48 kVA on the secondary side, and then I can just divide that 48 kVA by the total number of volts on my secondary side. But that's, it's depending on the number of turns that the transformer has, right? Like if it has 10 turns on this side and it has 30 turns on this side, right? Then that's going to be a step up of 1 to 3. So if I had 100 volts here, I'd have 300 volts here. If I had 40 amps here, right? Then, or 40, yeah, if I had 40 amps on this side, well, let's do something that's a little easier on the math. Let's say I've got 30. If I got 30 amps on this side, I want to have 10 amps on this side, because as my voltage gets larger, my amperage gets smaller, right? As the voltage goes up, the amperage goes down. So let's do one more. We're going to do a step up transformer. We have 120 volts. It is a 8 to 1, 1 to 8 step up transformer. And so 120 times 8, 960 volts. If we wanted to look at the amperage, if I have 40 amps on this side, right, then I'm going to have 40 divided by 8. It's going to give me 5 amps on this side. Right? I could also ask, what is the volt amps on the secondary side, right? What would the volt amps be? And I can, if I wanted to find what the volt amps on the secondary side is, I just have to take my 40 amps on my primary side times the 120 volts on the primary side. I get 4,800 volt amps, and that's good on both sides, right? My volt amperage is the same on both sides, right? And so we take our 4,800, divide it by 960, and we get 5 amps, right? We can, all that math will roll together, right? None of these on your test should be very hard. If any of you guys have any questions, send me a message in the next day or two. You guys have until Saturday to get your test done. You can take a look at this for the next few days before you start on your test. If you're struggling with any of it, shoot me a message, talk to me. I'll see if I can help you out a little bit more. We'll see you next week.